Okay. Hi, everybody. I think we are live. Welcome to the School of Data Science Open House with Udacity. It's so great to have everyone here. I think we have people from all around the world. So good morning, good afternoon, good evening, depending where you are. We are going to go over a few things during this open house today, and we'll go over the agenda on the next slide. Great. So we're going to do three main things today. The first is we're going to be going over what a Udacity nanodegree program is, what it includes. We'll do a deep dive into each of the programs in the School of Data Science. We have 5 nanodegree programs. And then at the end, we'll do a Q&A with our hosts today. My name is Molly Larkin. I'm with the School of Data Science with Udacity. And I'd like to now introduce our 3 hosts for the day. Josh, do you want to introduce yourself?
Sure. So hi, everyone. I'm Josh Bernhard. I'm the curriculum lead of the School of Data Science, and I have helped work on a number of the 5 programs that we'll be taking a look at today. It's a pleasure to be here with you all. You want to go next, Juno?
Yeah. Hi, everyone. I'm Juno. I'm also a content developer at the School of Data Science, and I've worked on several of the programs today too, and I'm super happy to be here.
Salvi, do you want to go next?
Yeah, hi everyone. My name is Salvi. I'm a student actually. I've taken a couple of nano degrees in like such as data analyst and intro programming, and right now enrolled in data scientist nano degree.
I'm not sure if that's my Wi-Fi. That's kind of laggy. So the first thing that I'll cover is what is the Udacity nanodegree program. So a Udacity nanodegree program is a career-focused program with strong community support that'll help you build relevant skills that are needed by industry. So what exactly does that mean for Can you guys all hear me now?
Hey, Josh, got everything okay with you?
The Wi-Fi must be acting up.
I can hear you just fine, so you can keep going.
Okay. So a nanodegree program is built with industry. So that's one of the main things from that last slide. And so one of the most important things that we try to do at Udacity is build all of our content with industry professionals and build things that are relevant for the candidates that they're looking to hire. So in some of the programs that you'll see in the upcoming slides, you'll notice that it's an immersive experience, and that is we develop projects alongside these industry partners, and then we try to build lessons that work up to getting you to meet the specifications on any of those projects. So some of the projects that you'll notice have even been developed right alongside an industry partner, or we take an industry partner's current problems and we put them into the classroom. This slide here shows you what that classroom experience looks like. Essentially, we have a breakdown of those for the content, and I'm sure either Juno and I during the Q&A would be happy to dive into how we develop each of those different pieces that go into the classroom. If we go to the next slide. So I was just talking about how we build these real-world projects. They're practical and hands-on, and they ensure that they give you sort of the skills that are relevant in landing a role as either a data analyst or a data scientist. And the big thing about each of these projects is we actually have an advisory board of professionals that we talk with who work as data analysts and data scientists in the field. And they give us ideas for what projects we can build. And a lot of times they work right alongside us in figuring out what those projects should look like. And therefore, your portfolio is then sort of tailoring you directly to what they're looking for in candidates. And then is Juno muted?
Sorry about that. Hi. So community is one of the best parts, I think, about taking a Udacity program, because you have a huge cohort of students taking this program with you. And in the classroom, you'll have a study group for each of the projects with a mentor who really knows that project well and is also a reviewer for that project. And we also have Knowledge, which is kind of like Stack Overflow for Udacity. So you can post your questions there and have discussions on with different answers, and staff contributes, other students can contribute, and mentors. And another big benefit is the project reviewers. So every project that you submit in Udacity will have personal feedback from a reviewer. And I found this to be super helpful, because even if you do everything correctly, they give really good tips and advice to take it further. And just, it's really nice to have one person like just going over everything and making sure that it's really good for showing to employers. So yeah, definitely awesome to have project reviewers. And if you go to next slide. So getting a job is why you're taking this nano degree for a lot of you. And that means that your LinkedIn profile and your GitHub profile is super important, because you're doing all of this amazing work in the program. And
Hey, Juno, I think you accidentally muted yourself.
That's so weird. Why does it? When did that happen? When I started talking about career support?
Yeah, you can just keep talking about career support.
Yeah, so we have one-on-one reviews for your LinkedIn and GitHub profiles to make sure that you make the most of all the work you did during the program, and you really showcase your projects in the best way. And we also have a career portal where you have access to a bunch of resources for interviews, application materials, and you also have an option to create an internal profile within Udacity to share with our hiring partners.
Next, we're going to take a look at some of the School of Data Science programs. So Juno and I are going to walk you through the 5 programs that we have in this school. And then at the end of that, I think we'll jump into some Q&A. If we want to go to the next one. So essentially, we have 2 tracks within the School of Data Science. One is for those of you who are interested in writing code, and the other is for those of you who are interested in analyzing data in a way that doesn't utilize code. And so if you're just starting out and you're not really sure which of these 2 tracks you might go into, one thing to ask yourself is sort of along the lines of like, what kind of career path do you want to set yourself up on? So people who usually analyze data without code tend to be people like product managers, product leaders, program managers, people like that are frequently using tools. And so then you might see yourself on sort of the right side of this page in the business analytics and predictive analytics for business programs. And if you do want to write code, so that is if you're interested in anything related to software engineering, data science, even some of the software engineering-based data science roles that have the titles sort of like mash all together sometimes in that field, but then frequently you'll be on the left-hand side where you're writing code. And I'll talk, Juno and I will both talk about some of the code that you'll see in those programs. So first, let's go to the right-hand side, and I'll talk about the business analytics program. If we go to the next slide. So the main things that this program covers are, it starts with some basic Excel and basic statistics, and then it moves into SQL. And so you do write a little bit of code in this with some SQL queries, learning to work with databases. And then the final part of this program is data visualization in Tableau, which is a really powerful business intelligence tool that's used by industry professionals in lots of fields. This program is usually a starting point for those of you who are not really sure what you want to do, but you know that you want to study data. And basically, there's 3 projects in that program, as Juno was talking about the projects earlier. There's an introduction to data project that just gets you used to working with data in Excel. You're actually analyzing data about from student forums about the types of programs that they've taken with Udacity. It actually gives you a pretty good glimpse of some of the other programs at Udacity and the feedback that people have given on that. The second project is a SQL project where you analyze data from a digital music store. And basically, you're looking at like different genres of music, who's purchasing what, figuring out purchasing habits. And then the final project is a data visualization project using flight data to look at different flight patterns, which you can build some really cool stuff in Tableau using maps for that. Cool. And then the next program is the Predictive Analytics for Business program. This largely uses tools that allow you to do things like machine learning. And if we look at some of the projects that are in this program, you'll notice that they do things like problem solving with analytics. You learn how to do data wrangling and classification. All of these are using a tool called Alteryx, which is actually used in a lot of, so in my past experiences, I saw it being used at some of the big 4 accounting firms. I've also seen it used at a lot of financial industry side companies, and they have their business intelligence leaders frequently using Alteryx to do things like classification models, whether that's like figuring out risk. If we go to the next slide, you can actually see Alteryx being used for things like A/B tests, time series, figuring out customer segments and how to market to certain customers and how to sort of like optimize customer segmentation to figure out frequently how to drive revenue for a company. And all of these, again, in the predictive analytics course are using Alteryx, which is a tool frequently powered by programming languages like R, but where you don't have to code.
So next is the Programming for Data Science Nano degree. So we're going back to the left side of the roadmap that Josh showed earlier. And if you go to next slide. This was actually refactored from the original DAND program, the Data Analyst Nano degree program. But this is a very good intro for if you've never programmed before and you want to get started to becoming a data analyst or a data scientist. This is a really good program for that. And like Josh mentioned, the ones on the right side, you use a lot of really amazing tools for data analysis. But in this track, you're just doing a lot of programming. So if you go to the next slide, you'll get a very thorough overview of and practice with SQL, Python, and version control. And these are very, very important things to be comfortable with when you're doing data analysis. And the next program is the Data Analyst Nano degree program. Here you go. So this is a very good next program after you do the Programming for Data Science, which is where you'll be heavily using Python and SQL to do data analysis. And if you go next slide. In the Intro to Data Analysis, you'll get an overview of the data analysis process. Be familiar with NumPy and Pandas, which are 2 very important packages for working with data. And you'll also get a very good course that Josh actually teaches in practical statistics. And I really like this because it really uses, it really shows you how to use programming to do really powerful statistics rather than just traditional methods. And data wrangling is the next course, also super important. You've probably heard a lot that data wrangling is a huge part of the job as a data scientist or data analysis. And the last course is data visualization. We actually just relaunched this to be focused on Python and Matplotlib, whereas it used to be Tableau and R. And I think this is also a very amazing course because just as a data analyst or data scientist, being able to be very flexible with plots and just create visualizations for all the different kinds of things you're working on is super powerful.
So next, I'll talk about the data scientist program, and Juno's going to lend a hand on this program as well. So if we go to the next slide, the data scientist program is a two-term program where the first term is about machine learning. So it teaches you machine learning fundamentals. And then the second one gives you real-world practice at applying data science techniques for problems that data scientists experience in the real world. So if we go to the next slide, the first term is comprised of 3 projects. One is on supervised machine learning, where you build an algorithm to find likely donors to a charity. And we actually set up a Kaggle competition to see who can best find those donors and figure out how much how charitable they will be. The second project is a project on image classification. And right now that project is actually identifying different types of flowers. And then the third project is an unsupervised learning project. And it's with a company partner named Arvado. And so far the feedback that we've gotten on this is that maybe it's too realistic of what you do in the real world because of how messy the data is and how much cleaning there is to this project, and how it gives a very real world glimpse of the types of data that you get in the real world, and how how you have to manage your time very well to get sort of like everything in order and get it into a usable fashion. And with that, the second term is something that I'll hand off to Juno.
Yeah, so term 1 gives you a very good grasp on the fundamentals. And term 2 is to really make you a well-rounded data scientist. And the first part focuses on just the data science process. It's pretty open-ended, but it gives very good guidance and guidelines on just how to solve and go about data science problems and how to communicate to stakeholders. And the project for that one is writing a data science blog post. And then the second course, or next 2 courses, are software engineering and data engineering skills for data scientists. And I also really like this one. Data scientists are sometimes notorious for not being very great software engineers and following best practices. So this is making sure you're very good and comfortable with those. Also, a very quick overview of very quick intro to web development, more of object-oriented programming. For the data engineering side, there's more information on ETL and machine learning pipelines, and also a little bit of natural language processing. So a lot of stuff there, but super helpful for when you're becoming a data scientist. And the next course is experiments and recommendations. So the first part is experimental design, and the second part is recommendations. And this one is super cool because we actually partnered with IBM for the recommendations project. And in general, recommendations is a very huge field in data science and definitely super fun. And the last project you'll do is actually an open-ended capstone of whatever you want to do. We have a few options, but yeah, you're open to picking whatever you want. So quick overview of the prerequisites. So on both sides, the first one, programming for data science and business analytics, are friendly for beginners. On the left side, for the data analyst program, we do expect that you have some Python programming experience. But actually, the Python course is also available online for free. So if you want to take that, that should help you prepare for the data analyst nanodegree program. There's also great resources online to supplement your programming skills if you are totally new to programming. So things like HackerRank or CodeWars can be super helpful. And then for the data scientist program, we do expect you to be pretty comfortable with Python programming and statistical analysis. And on the right side, again, business analytics is for beginners, and then the next program requires Excel and statistics.
So with that, actually, Salvi is one of our graduates from the data analyst program, and he's currently enrolled in the data scientist first term. Salvi, can you give a little bit of background information about how you started the program, where you were when you started the program, what do you do now for a job, maybe what skills you took from the program, and maybe how they helped you on your career path?
Yeah, for sure. First of all, thank you, Josh and Juno. That was very informative. Hi, everyone. My name is Salvi. I'm a previous graduate from the Data Analyst Now Degree program, and before that, the Intro to Programming Now Degree program. and now I'm also enrolled into the data scientist nano degree program. So well, my background is actually in business. I majored in accounting and finance, and during my 4th year of university, I realized I realized the power of data science and where it was leading to the future. So I wanted to transition more into that, and that's when I came across Udacity. So I started taking the intro to programming nano degree to get my programming foundations, and then I took the data analyst nano degree program, which actually led to my current job, where I work as a data analyst at a software company, and through that program, the skills I gained are directly applicable to the job I do right now, which involves a lot of data wrangling and data cleaning. And so I use Python and Python libraries such as Pandas very extensively, as well as SQL to extract data and analyze different kinds of data. So the data analyst nano degree definitely prepared me really, really well to perform really well at this job, and everyone can see that. And right now I want to move into more of a data scientist role, which is why I'm enrolled in the data scientist nano degree program.
Great, cool. Molly, do you want to take over? I think maybe we have some questions, and maybe you can even tailor those to who might be best to answer them. Thanks so much for sharing your story, Salvi. That was great.
Yeah, Salvi, thank you so much. So everyone, there's a lot of questions coming in on the chat. Please continue to ask them. We will answer as many as we can via chat, or having Josh, Juno, and Salvi answer them. So the first question that I'm going to have Josh and Juno answer, and Salvi, please feel free to jump in with your perspective. I'm most interested in the data analyst route. However, I do not have coding or SQL experience. Can a beginner in the data world take the data analyst program without being overwhelmed? And I'll give that to anyone who wants to answer it. Salvi, you as somebody who took the data analyst course might be a great person to answer that. And then Josh or Juno, if you want to add something as well.
Yeah, for sure. I can start off by answering that. In my opinion, it's definitely possible without programming background or without knowing SQL. However, as Juno mentioned, having a little bit of having some Python skills to start off with would definitely help, or else it would be a kind of a steep learning curve. But as for SQL, I know when I took the original data analyst nano degree program, it had a SQL component to it, which went into everything you would need to know about SQL. So SQL skills, previous SQL skills, definitely not really needed. You can pick it up through the nano degree if it is still structured the way it was when I took it.
Juno, do you want to add anything to that?
I mean, yeah, I think, yeah, everything he said was right. I think, yeah, and if you're a little worried about being new to programming, like I mentioned before, in addition to the free course that we have, there's also a lot of great online resources for practice. I know I did a lot of that when I first started programming.
Yes, just to add on to that, we do have the Programming for Data Science nano degree, which is focused on Python and SQL. But we also have a great free course on Python, which is a great place to get started as well. So definitely go look for that. The next question that's come up from a few people is just about the difference between our machine learning nano degree and our data scientist nano degree. And a few people are curious about sort of what the comparison is and what the difference is between those two programs. So I'll give that to Josh to start.
Sure. So, as I sort of talked about, the structure of the data science program is a two-term program where the first term is focused on machine learning. So the question pretty obviously from there sort of stems as to like, well, if the first term of data science is all machine learning stuff, then how is that different than the machine learning nano degree? So in general, the same topics are basically taught in the machine learning engineer program as are in the first term of the data scientist nano degree. The major differences are the projects, and the second is that the only deep learning that you do in the data scientist first term is aimed at that image classification project. the second term of the machine learning engineer program actually has a lot more deep learning in it, which you would be well set up to do if you decided that was the route you wanted to take after the first term of the data scientist program. So I would actually argue that it makes a lot of sense to do the first term of the data scientist nano degree program to even figure out if you want to do term 2 of the data scientist program, or if you maybe even prefer to do term 2 of the machine learning engineer program, depending on how much you like deep learning in that first term. So if you find that deep learning is really what you want to do, then going into the deep learning nano degree program or into the machine learning engineer term 2 is something that you can do directly. If you decide that you want to do more data scientists, more statistics, actually a lot of the data scientist term 2 program is aimed at helping you work with other software engineers and other people across a company, whereas the machine learning engineer program is more focused on just algorithms and how you work with different algorithms and what are they and when do you use them. We only do that in the first term, and then sort of in the second term, it's more like how do we build people into data scientists that can work across entire groups of a company.
Can I add something really quick to that?
For sure.
Yeah, so yeah, like Josh mentioned, term 2 of the data scientist nano degree program is a lot about giving you the skills that like make a data scientist a good data scientist, which is like having a very good problem solving mindset and just like a very research mindset, and having all of those skills needed for like communication, presenting, finding creative ways to design problems, ask questions, yeah, all of that stuff.
Yeah, and to the original question, basically like why would you do one versus the other, machine learning engineer versus data scientist? The first term very much is transferable information across both. The differences are in the second term. So depending on what you want to do, as Juno described the second term of the data scientist program, the second term of the machine learning engineer program is very algorithms focused still. It's still not very based on like what you do to integrate yourself into a team. Or integrate yourself into being a good data scientist in practice. Right,
yeah, so term 2 is like a lot of application, a lot of skills, and a lot of additional like data engineering-y and software engineering-y skills that help you all of that.
Good timing, Molly. We are just ready for another question.
Wonderful, sorry about that. Asking about, are the projects actually valuable and interesting to companies? So can you just speak to kind of how relevant they are to the real world?
Salvi, do you want to take that one?
Yeah, actually, yeah, I'll answer that. They're actually very, very relevant, and all the projects I worked on for the data analyst nano degree program, I put them on my resume, and I got calls because of those, because I didn't have any other experience doing data analysis other than those projects. But I got a surprising number of calls through those projects, and during my interviews, most of the time we would talk about those projects and what kind of tools I use, what kind of skills I use to be able to do those projects. So those projects are definitely very, very practical, and companies love seeing the projects that you worked on, and doing those projects on your own time also shows different companies that you're taking initiative to learn, which is a very big deal to them.
I mean, that's great for me to hear.
Me too.
Yeah. So just as a follow-up, we really do try. So Juno and I, as content developers, we really do try to build projects. If that's based on our own experience as a data scientist or in working with a partner, we really do try to build projects that will beef up your portfolio and make you stand out against competitors, being your peers in the job market. And it's our goal to help build projects that are technically appealing as well as can show off your soft skills in a lot of instances, or show off, as Juno was talking about in the second term of the data scientist program, show off your software engineering abilities. But in a data analyst role, like being able to show off how well you can work with databases and SQL, how well you can work with tools like Tableau, how well you can write Python code to like, whether that's automating tasks or analyze data in different ways. As Salvi sort of got to see firsthand in the data analyst program, all of those things are tailored towards exactly a project that you might get in the real world. And hopefully will beef up your portfolio to stand out against anyone else who's also applying for the same jobs as you are.
That's actually a great segue. There's a few questions as well about how best to use your GitHub profile with some of the Udacity projects and how that might kind of tie into the best ways to approach interviews. And this could be for any program, not just the data scientist program, but I think just in general.
Gino, did you want
to take that?
And sorry, the question was how to use GitHub for this?
Yeah, and sort of, what are your recommendations for how to use GitHub with the Udacity projects that you build? And then sort of how you approach your interview and how that can be an asset.
Right. Yeah, GitHub is definitely super powerful for showcasing your skills to employers. We actually make this a requirement for several of the projects in term 2 of the data science program. It's taking that. So a lot of times you put in so much effort into small little details in your project that no one will know about if you don't tell them. And I think a lot of people just expect people to look at your code and just be like, oh, wow, that's impressive. But really, even if you have like this much code, there's a lot of thought and very great decisions that you can be making during that whole process, which is why it's so important to document that in like a README file in your GitHub portfolio, or even creating like a blog post as we do in one of the projects, or a slide deck, or communication is super, super important for to supplement your data science work, because there's like a lot of the great thinking is like in your head. So yeah, definitely having a strong GitHub portfolio with like lots of documentation of what you did, why you did the things you did, can make a huge difference.
So I actually want to take a stab at this from a world and philosophical standpoint, which is maybe not what anyone wants to hear. Is a lecture at whatever hour of wherever you're at. So I've been a part of education for a really long time. And I think just in general, there's becoming, and it's not a shift that's happening everywhere, but you'll actually notice across headlines and so-and-so company no longer requires a 4-year degree anymore. So-and-so college no longer requires ACTs and SAT scores anymore. And I actually am kind of, I mean, I'm not individually doing this. If I individually could do it, I would try. But being a part of a group of people who believes that the best way to get a job or to show off your skills is to show someone what you can do, is to build a project that does it, right? So it's not to answer multiple choice test questions. It's not to sit in a room and get asked an algorithm and then have to code it up on a whiteboard. It's to get a project that simulates what you do in the real world and forces you to actually think through everything that you would do and come up with a creative solution. And I think that's what we try to do at Udacity, is to build projects that do that. And so one caveat that I'll say is, like, one thing that I would love to do with Udacity projects for all of them is to make them more open-ended than they are. And unfortunately, sometimes because they have to get reviewed by an expert, that's a really hard thing for us to do and to assess how well you do it. But that's something that you still can do on your own with your own projects, and to take them to the next step is to make them more open-ended and to show your own creativity and your own sort of like view of what you can bring to a project. And I think that employers are actually like really hungry for that. It's to show that someone just doesn't go by the book and does like what they're supposed to, but rather is like, I'm willing to take risks and to try to solve things in new creative ways. Lots of companies already have processes in place that automate things that can be automated. So they really want candidates who can push the envelope and be creative and solve new problems that haven't been solved before. And you do that by taking your projects to the next level and being creative. And a lot of times that doesn't mean like you get a 4.0 GPA or you go to a certain college. It means that you solved certain problems in creative ways and you can show it off to them. So that's my rant for the morning. Thanks.
If I could just add on to that, just to give an example. There was a project in the data analyst non-degree program when I took it. It was a wrangle Twitter data for We Rate Dogs, and that was on my portfolio. And when my current employer, they looked at my portfolio, they saw that it involved working with regular expressions, and that is something that we're definitely looking for, because in my current job, I use regular expressions pretty extensively. So just having that portfolio and showing what you can do instead of telling them can also, they can directly look at your work and see how you would be able to help them in whatever skills you have.
Which is also why Salvi would get that job. And if I applied, I wouldn't, because I'm terrible at regular expressions. So that's great.
Yeah, I just wanted to mention a lot of these questions, like using GitHub and the importance of portfolios and projects. We actually did a webinar a little while ago called "The Day in the Life of a Data Scientist." So if you want to check that out, we talk about that there too.
Okay, we have a very good question that's asking about what does Udacity offer that other online courses don't? Why should they choose Udacity instead of any of the many other places out there where they can learn data science?
Actually, I can talk about this a little bit, because I don't have a very traditional education background, so a lot of my learning was online and through jobs. And yeah, definitely, I think, well, there's several things. One of them I definitely think is projects. Having so when we create a nano degree or when we design a nano degree, we try to think about like the projects first. Like what skills do we want students to have at the end? Like when they graduate, they should be able to do this. And to graduate from the program, you have to build out these projects that we defined with skills. And I think just in general, starting with that end goal forces us to make sure that when we're teaching these courses, we design the lessons and the quizzes in a way to make sure that you can do this on your own later. And I think in general, like how interactive everything is, how strong the community support is, and how deep the projects can go, like it focuses a lot on action and you doing and practicing so many things that I think is really reflected like by your projects at the end. Yeah, it's not, we're not like passively learning or like watching a bunch of videos, maybe answering a few multiple choice questions. We're really trying to get you to code a lot, or in the case, or using the tools in the other case, but we're trying to make you produce as much work as possible, because that's what's going to prepare you the most for your job.
Yeah, I can take a stab at this too. So I think internally, when we think about the world of education, there's the possibility that you think about education as a bunch of videos that sit online, which is okay, and that's like a perfectly useful way to gather information, is to watch videos online. But the way that you truly learn anything, as someone who's been in education for a really long time, the way that you truly learn anything in life is by doing it. And most other providers are not going to require that you do it, and they're not going to have communities that motivate that you do certain things. So depending on what type of learner you are, and depending on the type of motivation that you have, I know I personally struggle with motivation when I'm just watching videos. Like there's no way, like I'll watch somebody write code or I'll watch somebody solve a problem and be like, yeah, I can totally do that. I can definitely do that now. But there's nothing, so my order of hierarchy in terms of like how well you know something, the top level is like, can you teach it to somebody else? Then you know it. And then the second level is like, have you done it before? And then the third level is like, have you watched somebody close by you do it? And then like the lowest level is like you watched a video of someone else doing it while you were doing something else, right? So most other online providers are sort of fall in those bottom buckets where you're just watching somebody else solve problems. At Udacity, we really do care about motivating you through projects that will then stand out to employers and making you do the work, which is both a pro and a con. Right? Like some people will say, I can get all of this content somewhere else and maybe more depth. And it's like, yeah, we don't do as much hand-holding here. Like we don't. Juno and I do this in practice, and Salvi can talk to this too and his experiences. But like in the real world, you don't get someone to hand-hold you through things. And that can be really hard for people the first time. Everything is already available on the internet. So how do you get through problems? You get through them by solving them. And other providers, I strongly believe that most other online providers are basically just like a handhold tool to get you to solve some super specified problem and just walk you through it. And I don't think that that's how education should work. You don't learn best that way. You learn best by us sort of like letting go and letting you solve problems on your own and figure things out on your own. And honestly, that's how all people learn best, right? Like if you think about things like walking, if someone was always there holding your hand, you would never learn to walk on your own. You would just always have someone there to help you.
Yeah, I also have done a lot of online courses before, and I think it also makes a huge difference in how well you retain the information, because if I just like binge watched a bunch of content and I did the quizzes while they're doing it, I will understand everything while I'm taking the course and it'll be great. But like a few months later, I don't have things to look back on. I think the projects like really help out here, because when you look back at all the work that is very carefully linked to the lesson material, it just like sparks, like I just remember things way easily when I see things that I actually produced. And at least we try to make sure that the projects are very well connected with the content. So if you need to review anything in your project, you'll always have your lessons available as well.
Yeah, and if I can add to that, there's a reason why this is my third 9-degree program that I'm enrolled in, and that's because I basically fell in love with the format that Udacity uses to teach the skills that are required. And working on those projects taught me a lot, as Juno and Josh mentioned. There's not a lot of hand-holding involved, so you really get to do things on your own, and sometimes you have to do your own research, and that also helps reinforce the skills that you're learning, because you're actually doing your own research and trying to figure out things on top of whatever foundation those course videos provide. And then the graders, after you're doing the project, the graders give you great feedback on what you can improve on, how you can improve your code, and how you can approach different problems. That also lets you see where you made your mistakes and what the right approach would be next time going forward. So the structure that Udacity uses is, I feel like, a very good structure to make sure you really learn the skills that you need and you retain them, as Juno mentioned, moving forward.
Great. There are a few questions about the algorithms that you build in data scientist nanodegree and also machine learning. Do the students build them themselves, or are they sort of calling them from a library in general?
Yeah, that's a good question. Yeah, so there are obviously, right, so depending on viewers' understanding of programming up to this point, but there's this idea in programming called encapsulation. And what encapsulation means is you don't really have to know what's going on under the hood of something. You just need to know the name of it and what to pass it, and it'll just solve things for you. And there are really good libraries that exist in Python specifically for machine learning that do encapsulation very well. So the main library for that is scikit-learn. And scikit-learn allows you to use very cutting edge things in an extremely encapsulated way. So in the real world, those libraries are used all the time. And you would be sort of foolish to try to rewrite the scikit-learn library by yourself. Your code wouldn't run as fast, it wouldn't be as efficient, and you're rewriting something that somebody already did and shared with you. There are reasons from an understanding standpoint as to why you would want to understand what's going on under the hood. So I will say for the projects themselves, you are frequently using the built-ins to produce end results and then interpret those end results and then understand how they have like impact on a business. From the lessons point of view, you are frequently coding things from scratch, or at least understanding the math that's associated with how those algorithms work under the hood. So a lot of times the video content and the coding quizzes that you do along the way are aimed at helping you understand why an algorithm works in certain ways, and even potentially writing things from scratch depending on who the instructor is. At the end of a lesson, when you start doing projects, they're frequently aimed at using built-ins. And that's because in practice, you would frequently use a built-in. There are certain situations where you might have to write something from scratch. And actually in term 2 of data science, which I built, it uses a lot of algorithms that don't work from scratch. And so you end up having to write them yourself. Juno, do you have anything you want to add to that?
Yeah, I mean, it's pretty much the same thing. I do agree that sometimes doing things from scratch is very valuable. And I think in general, differentiating yourself as a data scientist, it's important to understand the theory behind what you're using, because that's what helps you know how to apply them in the best way. And that's something you get a lot of practice doing as well, like understanding the pros and cons of different things and which ones work for different scenarios. But yeah, like Josh said, it would be pretty foolish to try to write things unless there was a very, very specific reason you were doing it. But for the most part, way more efficient to use these packages and also just share with the community and for employers as well.
Yeah. I mean, so it might be beneficial to look at like something concrete. So if you think about, and again, I don't know everyone's background, but like a very simple machine learning algorithm is something like a decision tree. And is it important to understand the different ways in which you can make splits in a decision tree? Is it important to understand like Gini coefficients? Is it important to understand how you weight those Gini coefficients depending on which branch depending on what type of problem you're solving? Is it important to understand how you would measure classification algorithms different than regression algorithms? Yeah, that's important. Would you want to write a decision tree from scratch that you would then use in practice? No, probably not. Like that would be sort of a silly thing to do because there's already an algorithm that does it for you. Now, if the decision tree algorithm always optimizes on accuracy and you are in a situation where you need to optimize on something else, now you're in a situation where you can no longer use the built-in. And so you might have to write something from scratch. And it's important to understand the algorithms that are under the hood so that you can do that in those situations. Yeah. So I would say that we teach you enough that you could go out and build something like that yourself. However, we do not require that you build something like that yourself to get through the projects.
Great. We have time for a couple more questions. So one thing that's come up a few times is sort of what the support is if you can't sort of finish your project, if you need help with a project specifically, or if you submit a project and it's not up to the standards, sort of what happens?
Salvi, do you want to take that one?
Yeah, for
or
sure.
Did all of yours get passed right away?
No, definitely not. It would have taken me a lot less time. But yeah, so yeah, there's great support. You always have the mentors who are always ready to answer your questions, and even the community. You have the Slack community, and then you have your Udacity's own community. Now for the data science program, I can see that. So there's a lot of support going that you can, where you can ask questions, you can have discussions about whatever issues you're having, because a lot of times whatever issues you're facing is very likely someone else has already faced that or are going to be facing it. So you can have great discussions around that. And then once you get around to projects and submitting them, you have graders who are very, very quick to give you your feedback. And the feedback's always really elaborate, and they really make sure you understand what it is that you're doing wrong. And they also hint at how you can improve that without giving you the answers themselves, so that you can try to work on that and improve as much as you can. And it doesn't matter how many times you need to be graded, unless your projects meet the specific criteria. You're going to have to keep redoing it, which is a good thing, because that makes you develop your skills to a satisfactory level. And the graders, as I said, are always there to help you out and always there to give you great feedback. And if you follow those feedback, generally you'll do pretty good. But a lot of times, I mean, I've had projects that I had to get reviewed 3-4 times before I could pass them, and that gave me the opportunity to see what I was doing wrong and how I could do things better, moving on to the other projects that I was going on into.
And again, you also have a community. You have a lot of students who are doing the same projects you are. While we don't encourage sharing like the explicit answers, there are people who can help you out if you get stuck on a certain area. Or the mentors who are in the study groups are also the reviewers for the project, so you can talk to them there too.
Yeah, and again, I think, right, so like part of this is developing the right mindset towards getting things quote unquote wrong, right? Like you shouldn't look at like getting a project back as like, oh, you're a failure, right? We don't encourage that sort of mindset. We encourage the mindset of, oh, you know, this doesn't quite meet specifications. This is a chance for you to grow in a certain skill set. And I think that you actually can see that in Salvi's answer. He's like, it was an opportunity every time that I got a project back, which could be 3 or 4 times, for me to improve on areas where I had submitted something that didn't meet the specifications, which is exactly the mindset you should have towards getting a project back. It's not like, right, it's not like a test where you fail or something like that. It's a chance to prove, right? And you should think of that as like you're similar to like the way that an employer would give you feedback, is like, oh, this area isn't quite what we expected. Can you improve upon it so that in the future you know how to do this better?
Right, and that's how it works in the real world too. Like all the projects are great because they're iterative. You work on them and you continuously improve them. And actually, if you fail 3 or 4 times, that's great. You get 3 or 4 times the amount of feedback. You learn a lot more that way.
Salvi, can you talk about how long it generally took to get one of your reviews back? Were you waiting like weeks or days or?
For sure. A lot of times they were really, really quick. I know in the officially you guys, Udacity says that it could take up to a week, but it never took me that long. Usually it was same day reviews. Sometimes it would go into 1 or 2 days max. So the feedback was generally really, really quick. So I mean, that really helped because you could make sure you weren't wasting a lot of time in the middle waiting for your review to come back so that you can continue your courses.
Molly, do you have any other last questions?
Yes, we have one more question that we can answer live, and it kind of goes back to something we've already talked about, but I think it's really important. How well recognized are Udacity's credentials to employers? And, you know, just a quick summary, you know, I think that the Udacity name is very recognized, but I'll let Josh and Juno and Salvi speak a little bit more to it. I think the real benefit of the Udacity programs are really the projects and the skills you can demonstrate. So I'll let you talk a little bit more about that, and then we'll wrap up before 11.
Actually, fun fact, I was looking through job descriptions, and actually I do see sometimes it says, I think one specifically it was like benefit if you took online courses MOOCs like Udacity, and I was like, oh, awesome. I think, but as Molly said, I think the biggest thing about Udacity, like what we're proudest about is not our credential, but what we actually like turn our students into, meaning like very, very very good skills that you can use in industry, and experience. through all the projects that you have. And I really believe that your projects can speak for themselves. And by guiding you to create really, really strong projects with great technical skills and great like communication skills and great just presenting in general, I feel like that is the thing that will give you the most leverage when you're applying for jobs. But that being said, there are companies who do recognize that that is our goal, so they will recognize the Udacity credential, but it's definitely not something like that would like replace a degree in terms of the credential power itself. It's mostly about like building your skills.
Yeah, I can speak on my experiences during my job search. I would say, as like Juno basically mentioned, the power of Udacity is in terms of what you can bring to the table, in terms of what you can do and what it teaches you to do, and the projects that you get from it. And that is what employers look for the most. As she said, it's definitely not something that can replace the formal education, at least not yet. But it is gaining more and more prominence and recognition because we're in 2018. The times are changing, and education itself is changing, and how you can learn. And I mentioned this a little earlier, that employers nowadays really value that you can take the initiative to learn on your own and not have to rely on a formal institution to give you the education. And it shows initiative. It shows that you're trying to learn. And a lot of times in job descriptions, my current job actually, when I first applied, the job description said you need a formal education in computer science, math, statistics, or whatever in a quantitative field, and you need 2 years of experience working with programming, different kinds of languages, Java, and this and that. And all I had on my resume was my projects, and the projects really were so very well fitted to what the job required that at the end of the day, those qualifications didn't matter as long as I could show that I could actually do what they needed me to do. So that is where the real power of Udacity comes in. It teaches you what to do, and it gives you a platform to show off what you can do. So it definitely, and as I said, the general prominence of MOOCs and platforms such as Udacity is growing, and it is gaining more and more recognition by the day.
Yeah, I totally agree with what Salvi said. I think taking an online course and learning all this content in such a short time frame and being able to build out these projects says a lot about your potential and how it can be very reflective of how independent and quick you can be at the job. So I think it's actually a very good, like, it's a very cool thing to say that, like, I learned all of this online. Here are all the things I built during that time.
Great. That's a great question to wrap up on. Can we put the prerequisite slides back up again, just so we can just quickly recap the 4 programs, or excuse me, the 5 programs? Okay, great. So just as a quick reminder, we reviewed the 5 programs in the School of Data Science. Hopefully that this has helped you sort of understand how each program relates to each other and which one you might be best suited for. I want to make a quick note that at Udacity, we have a lot more programs besides these 5. We actually have 5 schools, including the School of Artificial Intelligence. I saw some questions about neural networks and things like that. So definitely go check that out as well. Covers topics like deep learning, computer vision, natural language processing, neural networks. So those programs do exist at Udacity. They're just sort of grouped a little bit separately. So definitely go check that out. Then can we go to the last slide? Thank you everyone so much for coming to this. I think there's one more slide at the very end. There we go. On this last page, you'll see the website, udacity.com/School of Data Science. We also have an email address. So if you did have a question that we couldn't get to, I'm sorry if we missed it. But if you do have a question that you really would like answered, you can send that in to schoolofdata@udacity.com and we will get back to you. And you'll also see the upcoming start dates for all of our next programs. So go check out that website, see if there's any other questions that you have, and hopefully you'll join us. Business analytics starts today. You can enroll through midnight Pacific time tonight, so about another 12 hours. And then other than that, 3 of our programs start next Tuesday. You can enroll through next Tuesday, and then data analysts begins on October 9th. Any last words from any of our hosts before we sign off?
Thanks.
Yeah,
Great.
thank you guys.
Thank you everyone so much. And like I said, if there's any final questions, please send them in and we will get back to you. Thanks everyone.
Thank you.